Hey students, welcome back, welcome again. So today we are back in action with oxyacids of sulfur, and today we will learn how to decode or how to draw structure of any oxyacid of sulfur within few seconds. Now the basic to this is sulfur forms either 4 bonds or 6 bonds in all the cases of oxyacid. So if you have any oxyacid, sulfur will form 4 or 6 bonds. Now if you want to sketch H2SO3, that is sulfurous acid, first of all sulfur will be our central atom. Number of hydrogen are 2, so we will attach 2 OH. The basic key of drawing the structure is, it is our basic trick. If you have 2 hydrogen, then you will attach 2 OH with the sulfur. So we have 2 hydrogen, 2 OH. Now 1 oxygen is left. The leftover oxygen is attached by a double bond and your structure is ready. Look here, it has 2 OH group, therefore the basicity will be 2. Moving on to the next one, but I say you should pause this video and try to do all the cases by yourself. Now H2SO4, sulfur in the center, 2 hydrogens, 2 OH. So OH number 1 and OH number 2. Now what is left? 2 oxygens are left. What we will do? We will attach them with a double bond. Very simple. Next is dithionic acid, H2S2O6. Now it contains 2 sulfur first of all. So sulfur number 1, sulfur number 2. It contains 6 hydrogens. We will distribute them between the sulfurs. So 1 here, 2, 3, 1, 2, 3. Now 2 hydrogens, so 1 to this one and 1 here. Now the basic rule, as say sulfur will attach to OH, so this is 1 and this is 1. Now rest of the oxygen will attach with the help of a double bond, so this double bond and this double bond. Same goes here like that. Now sulfur has 5 bonds. What sulfur does? It forms 6 bonds. So this one and this one, these 2 brothers will unite and our structure is ready. So this contains a SS single bond, asked in many exams. Now moving on to H2S2O7, that is oleum. Sulfur 1, sulfur 2, 7 oxygens, equal distribution. So 1, 2, 3, 1, 2, 3. The 7th oxygen will be in between them. So half to this one, half to this one. 2 hydrogens, 1 here and 1 here. Now look here, sulfur will form first of all OH and then a double bond with the oxygen. Sulfur will attach with the OH and double bond with the rest of the oxygen. Sulfur has 5 bonds, sulfur has 5 bonds. This oxygen will form a single bond with this, a single bond with this, equally shared between the sulfurs, and our structure is ready. If you look here, you will find basicity 2, and it also contains, oleum also contains SOS linkage, that is SOS bridging. Now moving on to the next case, we have H2SO5. H2SO5, sulfur in the center, 2 hydrogens, there will be 2 OH group, 1 OH and 2 OH. Now 3 oxygens are left, that will attach in the form of double bond. Now what to do with the 3rd oxygen? Because sulfur has completed its valency, 6 bonds all formed, so this oxygen cannot be attached to sulfur. So what we will do? We will shift this oxygen here and it will look like that, and all the cases, all the problems are gone. However, this bond is what? A peroxide linkage. So the name comes peroxy monosulfuric acid, Carr's acid, H2SO5. Now the last case, H2S2O8. So first of all, 2 sulfurs, 8 oxygens, 1, 2, 3, 4, 1, 2, 3, 4, 4. Look here, 4 oxygens are surrounding this and 4 oxygens surrounding this. Now 2 hydrogens, 1 here and 1 to this. Now the structure goes like this: sulfur with OH and sulfur with a double bond, sulfur with a double bond, sulfur with OH, sulfur with a double bond and sulfur with a double bond. Sulfur has 5 bonds, sulfur has 5 bonds. For the 6th bond, it will form a bond with the neighboring oxygen. Now these two oxygens require one more bond, so they will form with each other. This is what? Again a peroxide linkage. The basicity is again 2. In this case the basicity is also 2. In this one also 2. So I hope you love it. I hope you get it. Share this with your friends and do visit our channel's playlist for more interesting and crazy videos.